On one of the later slides, you had 8 infrared channels and 3 solar channels. Yeah. What were the solar channels looking at?
I'll just bring that one back up for us. It was Severi, wasn't it?
Yeah, that one. 3 solar channels.
Is that UV or solar wind?
It's looking at, so by solar I mean more kind of visible wavelengths, so looking at the reflection of the solar light. So one thing that's quite useful for is for detecting aerosols, for example. I have a colleague at Imperial College. She's very interested in monitoring like Saharan dust storms and how they're transported out over the Atlantic Ocean, and having Severi is ideally located for looking at that kind of thing, giving regular views over the Sahara. And so that's one application of visible channels. I guess another application might be if you're looking at like surface temperatures, for example, land surface temperature. The visible channels give you some context, lets you work out the emissivity and the reflectivity of the surface you're looking at as well. So yeah, there's a couple of applications there.
Okay, thank you.
Okay. We've got that that sort of image running live in the other room. Yeah. Yes. Okay. Yes. What?
Presumably the instruments that you're flying in an aeroplane over Leicester give you very, very high spatial resolution, but you won't be able to get that from the satellites. You won't get the same resolution. But if you could, I mean, one very interesting aspect of all NHS data is now postcoded. It would be very interesting to overlay morbidity and mortality data on those pollution data. I don't know whether you can do that from the satellite resolution.
I guess with current capabilities, I wouldn't have thought so. I think the OMI satellite that we use as a reference for nitrogen dioxide, I think you're looking at pixels of the order of sort of 10 kilometres or so off the top of my head. And then, but perhaps with future missions, something that we'd want to target, and certainly it's something that we could certainly do with this aircraft data. Actually, it's as well as health applications. Another project that we've worked on is actually providing data as input into a traffic management model, whereby the councils, like Leicester Council, as well as being interested in getting the traffic moving, they're also interested in reducing pollution through having stationary vehicles sat in traffic and emitting all kinds of things, but yeah, especially nitrogen dioxide. So we've actually come up with a way of kind of feeding in the observations into the traffic model, so it can kind of react and like change the traffic flow to try and mitigate against that kind of thing on sort of a very local scale.
Okay.
How much of an impact has the demise of Envisat had on you?
It's a fair impact actually, because so for certain data products there's going to be a bit of a data gap until new missions are launched, which is perhaps a bit of an oversight, just because Envisat was already beyond its originally intended lifetime at the point we lost contact with it. So it's certainly very unfortunate for the Earth observation community. However, there's still a lot of work to be done on the 10 years or so of data that Envisat picked up during its lifetime, and there's a lot to be learned, I think, from the data we already have. So at the moment we're kind of still working on that stuff, but very much looking forward to the new European missions, the Sentinels, and the new second generation Metops as well.
Okay, one more question. Last one. Yes.
are you satisfied with the accuracy that you're getting? How would you want to improve that? Would it be a higher spatial resolution, higher spectral resolution, or would that to be improved algorithms?
All of the above would be nice, but if we had to prioritise, I think fundamentally, as someone who's worked a lot directly on instruments, I feel kind of the radiometric accuracy is of utmost importance, especially when it comes to investigating long-term trends. If you don't have the radiometric accuracy, it doesn't. Like the spectral resolution and spatial resolution become less useful. So you kind of need that before kind of moving on to spatial and spectral. But also, as someone whose background is very much in spectroscopy, I think, there's a lot of information to be gained from higher spectral resolution observations. So I'd certainly try and push instrument development down that route as well.
Okay, well, if we can leave it there,